Good day. You should have a series of pages that say titration examples, and I'm going to go through these in a series of videos. So titration examples, we're going to go for equivalent amounts, and that'll be like what we did in redox. It means we're going to stop at the end point. Later on, we're going to do non-equivalent amounts, and that means we can figure out the pH at any given point when we're creating a pH curve. So we have 25 mils of unknown HCl. That means we don't know its concentration. And that's mixed with 2.200 molar NaOH. And 3 trials are performed. And we get 16.2, 16.5, and 16.2 mils of NaOH. And we determine the HCl. So we remember about titrations, it's stoichiometry. We have to start with a balanced chemical equation. This is definitely a strong acid, strong base titration. So we write down our known information, our 25 mils, don't know the concentration, 16.2 mils, and 0.200 m. So you can see I took the 16.2, we had it occur twice, and I ignored the 16.5 and just went with 16.2 since it occurred twice. I get my moles of NaOH, it's a 1-to-1 deal, so I get my moles of HCl, and I divide by my volume, 0.0250 liters. And I get 0.130 m, if you're able to see it with all the glorious colors. So that's a very straightforward question. Let's see if we have another one on the page or if we have to hop to the next page. Looks like we're hopping to number 2 here. Number 2, we have NaF is titrated as second endpoint with H2SO4. So that means we're removing both protons from the sulfuric acid. So it's going to take 2 moles of sodium fluoride, and the sodium ions will be spectator ions. We're given an average volume, and it's the same kind of calculation. There's our balanced chemical equation, 2-to-1. In titrations, once we balance the chemical equation, we really don't care about the products. So here's our known volume, known concentration, that gives us our moles. And this time, once we have our moles, we multiply by 2/1, stoichiometry, so we double this. We divide by our volume, and our volume was conveniently 10.00 milliliters, which we put into liters, and we get 0.142 m. Then it wonders what this pH would be at the second endpoint. And it's a strong acid, weak base titration, so it's going to be under 7. The acid's going to outpower the base. So that's it for our first video. We've done 2 straightforward examples of simple titrations. Things will get a little more complicated as we move on.